Hi, this is me, Nezrin Rzayeva. It's my first term project from the water supply and the sewer system. Firstly, our term project just consists of the four parts. First, estimating of water demand, downloading DEM file. And third part is topo profile using DEM. Fourth is transmission line calculation by hand or exist I did by hand, and plus the sketching on the AutoCAD drawing. First, the estimation of the water demand. We check our population for 55 years after this time, and for calculation of population estimation for the 55 years after, we use that arithmetic, geometric, inner bank, and methods for estimating the best fit of it, and we derive the last part, the exponential curve, and we write the populations getting the K, and P, which is the correspond that coefficient of arithmetic, geometric, and Bank methods coefficients, and later we get this point that best fit to the exponential curve. We find that exponential curve which best fit, and finally we choose that. Our choice will be that Bank. In this slide, it's just easily and preciously seen seen that uh, we we put the input values, and also arithmetic, geometric, and Ilerbank's graphics, and it's shown here that Ilerbank is the most suitable. Ilerbank and geometric just overlapping, and they're best fit one to the exponential curve. Second step is downloading DEM file. Here I downloaded DEM file with SRTM, and downloading DEM file from NASA. Here it's shown. The third part, topo elevation profile using DEM. Here we create our paths. We find our profile for location of the transmission line, and we get that height and the kilometers which our line will be passes, and according to this we will derive our transmission line. And transmission line here, again I want to mention the heights of each elevation. We will draw a sketch on the AutoCAD, and after sketching, finishing the AutoCAD files, we will check for that. We will compute the slope, and we will check that where we need to settle the pump or pressure tank, where is that the openings or closing part of that pipe. That third part is the fourth part, and the last part is that transmission line calculations. It's just optional or doing by hand or Excel, but I did by hand, and also the sketch in the AutoCAD drawing. Here, this is my AutoCAD drawing. I did a transmission. I sketched the transmission line, pump pressure rooms here. I have the two pressure rooms here, and there's some valves. This the butterfly shapes, just looking like the butterfly shapes is the valves. The this ones is that the upside one is that air valves, and this triangular ones are the pumps. Um, this show that air release, okay, in the opening of the pipe system, and I showed the rectangular one as the pressure tank, okay, which it locates because of the P divided gamma max is must be less than that 100 meter. Otherwise, it can explode the pipe, our pipe. Also, in the same time, our P divided gamma minimum, it means that minimum pressure head must be the 4 meter, otherwise it will not flow in the it cannot flow in the pipe. And here my calculations is looking is I firstly write the formulas for just needed for calculation of pipe diameter. We will go on our way from that Q, which we will find from our design. Actually, I designed 3 atolls for restaurant, 1 school, and 1 dormitory, and I just sketch all this part like this, 200 person, 400 or 250 students, like their daily discharge. It's written here, and I found that each of it by hand calculations like this. But and also I have to 92,103 people which live in our territory, and I found their discharge by multiplying by 130, and I diverted to liter divided second, and finally for calculation I must do convert all of them meter cube divided second. But one things must be do here before the all after the all calculations is just increase 30%. It is because of when the pipe flows transmission lines transmit the water, there will be water loss, and for be in staying in safe side, and for supplying the water normally, we will multiply it with 1.3. It means that just increase the 30%. After it, we get A. We firstly choose that V max and Q divided V, and I get it A. PD squared divided for I found D, but this D is according to my V max, but I must choose something like the velocity less than the maximum velocity, and I will just properly 0.5. After it, we will calculate that phi is the friction. It's actually it's a friction coefficient in that in our formulas, Darcy-Weisbach. This phi is just final like so. There is needed a Reynolds number. I found the Reynolds number like so, and finally getting the phi, and I found slope finally. And according to this slope, I sketched that my AutoCAD file like it. This is the end of part of my presentation. Thank you for listening.